Assalamualaikum and hi everyone. In this video, you are going to learn relative atomic mass AR and relative molecular mass MR based on the carbon-12 scale. And also, we will try to look a few of the calculation in order to find the relative atomic mass or relative isotopic mass based on isotopic abundance. So as in the previous video, you have already learned the concept of the isotope. So we will bring the concept of the isotope in order to calculate the relative atomic mass in this video. Here we have two relative mass. They are relative atomic mass AR and relative molecular mass MR. So relative atomic mass AR is a mass of one atom of an element compared to 1/12 mass of one atom of carbon-12 with the mass of 12. And for relative molecular mass MR, it is a mass of one molecule of a compound compared to 1/12 mass of one atom carbon-12 with the mass of 12. And summation of all relative atomic mass of all atoms in a molecular formula will give relative molecular mass. So let's say if we have sodium, so if sodium has isotope, so then you can find the relative atomic mass of the sodium. And for CH4, so since this is a molecule, so for this molecule, you will be able to calculate its relative molecular mass. So relative atomic mass is a mass of one atom, and relative molecular mass MR is a mass of one molecule. And summation of all relative atomic mass in CH4, okay, will give you relative molecular mass as well. These are the formulas for relative atomic mass AR and relative molecular mass MR. So AR is mass of one atom of element over 1/12 times mass of one atom of carbon-12, and MR is equals to mass of one molecule of the element or compound over 1/12 times mass of one carbon-12 atom. So here, what does it mean by relative? Relative means that the value of AR and MR is unitless. So in order to get your final answer for AR and MR, you have to make sure the answer for both AR and MR must be unitless. They just have the value only. So that is the function of the term relative. So this is the comparison between the molar mass and relative molecular mass. So in this question, you are going to calculate the relative molecular mass and molar mass of C5H5N. Okay, and you've been given this value of atomic mass of carbon, hydrogen, and nitrogen. So in this case, in order to calculate the MR, which is relative molecular mass, so what you have to do is you have to do summation of all atoms that we have in C5H5N. So by having all this summation, later you will get the answer for MR, which is 79.11. And since it is relative molecular mass, the answer here will has no unit. And meanwhile for molar mass, so for molar mass, we will do the same approach like the MR. Okay, summation of all atomic mass. But then in our final answer, molar mass must has unit, which is gram per mole. But the figure or the value between MR and molar mass, they are exactly the same. Okay, the value are exactly the same. The value is exactly the same. But the one that makes them different is actually MR has no unit and molar mass has unit. So this is the difference between molar mass and relative molecular mass. So relative means that no unit on the final answer. In this example, you are needed to calculate the relative molecular mass of freon if given the atomic mass of each atom, carbon, chlorine, and fluorine. So if you can see in the question, all atomic mass of carbon, chlorine, and fluorine are given with the unit AMU. So if you are going to find the relative molecular mass value, you have to make sure all these units must be gone. So now, let's do the calculation. So first step, what you have to do is, you have to calculate for molecular mass. This is the mass of, atomic mass of carbon atom. The formula is CCl2F2. So times 2 and atomic mass of chlorine. And times 2 of the atomic mass of fluorine. So this will give you. So next step, we will find relative molecular mass. So the formula will be the molecular mass over 1 over 12 times 12 AMU. So by doing this step, you can cancel the unit AMU, and also you can cancel these two values. So hence, you will get your final answer of MR without the unit AMU. So this is the way you should do in order to cancel the unit to get the value of MR and even the AR. In the previous slides, you have learned the concept of relative atomic mass AR and relative molecular mass MR. But how do we actually get the value of the atomic mass? Atom is extremely small, and it is impossible to weigh the mass of the atom by using analytical balance. But with modern techniques such as mass spectrometry, this could help us to determine the mass of individual atoms accurately. So here, mass spectrometer can be used not only to find the relative atomic mass and relative molecular mass. We can also use mass spectrometer to study the isotope. So mass spectrometer can be used to find the types of isotope, its abundance of each isotope, and also the relative isotopic mass. And last but not least, we can use the mass spectrometer to recognize the structure of our unknown sample. This is the mass spectrometer machine. So this is the mass spectrum that we obtained from the mass spectrometer. So what we can see in this mass spectrum, we do have the relative abundance as the y-axis. So this relative abundance can be in the form of percentage or in ratio. And on the x-axis, we do have mass over charge value over here. So we can label it as m over z, or you can label as m over e, or you can just write it down as mass over charge. Okay, and the value at the bottom over here should refers to the isotopic mass. So how to interpret or how to read this mass spectrum is by looking at the visible peaks obtained in the mass spectrum. So in this case, we can see there are 3 peaks, okay, in the mass spectrum. So we have the highest peak, the medium peak, and the lowest peak. So this highest peak refers to magnesium 24, okay, because it lies on this atomic or isotopic mass. And then we have magnesium 25, and this is magnesium 26 with their respective percentage abundance. Okay, so by looking at this mass spectrum, okay, we can conclude that magnesium has 3 isotopes. They are magnesium 24, magnesium 25, and magnesium 26. And the height of each line is proportional to the abundance or amount of each isotope. So we can conclude that from this mass spectrum, magnesium 24 is the most abundant of the 3 isotopes because it has the highest peak among all isotopes. And then when you are about to draw your own mass spectrum, you have to make sure to draw this y-axis and x-axis using these single lines. Okay, so it should be no arrow on your axis like this. Okay, you can never draw arrow on your axis for the mass spectrum. Okay, so just leave it as single lines like this only. Okay, so this is the way you draw the mass spectrum, the axis of the mass spectrum. Since magnesium has isotopes that are magnesium 24, magnesium 25, and magnesium 26. So which values between these 24, 25, and 26 that can be actually used as atomic mass in our calculation? So to answer this question, we can calculate the relative atomic mass of these isotopes. So in order to calculate the relative atomic mass of these isotopes, you have to use this formula. So AR equals to summation QI times MI over summations of QI, whereby the QI stands for or refers to relative abundance of the isotope. Relative abundance of isotope can be in the form of ratio or percentage. And MI refers to relative isotopic mass of the element. So 24, 25, and 26, these are the relative isotopic mass. And the abundance in the form of ratio or percentage, you can find it from the mass spectrum. In this example, you are needed to calculate the relative atomic mass from mass spectrum. So here we already have the mass spectrum of rubidium. So what isotopes are present in rubidium? So in order to answer this question, you have to study this mass spectrum. So in this mass spectrum, we do have the relative abundance and the mass over charge. And so surprisingly here we have unit AMU for this mass over charge. And we have 2 visible peaks in the spectrum showing that rubidium has 2 isotopes, and 18 and 7 here are the abundance of these 2 isotopes. And these 2 values is actually in the form of ratio. Why it is in the form of ratio? Because addition of these 2 is not equals to 100. So to answer the first question here, it should be rubidium 85 and rubidium 87. So next, you are required to find the percentage abundance of each isotope. So since we already have these 2 ratio values of the isotopes, so hence we can convert these ratio values into percentage. So we just have to use the simple mathematics method to convert the ratio into percentage. So the percentage abundance of rubidium 85 will be 72%. And the abundance of rubidium 87 will be 28%. So the summation of these 2, you will get 100%. Okay, when you add these 2 values, 72 and 28, so the hasil of the summation will be equals to 100%. Next, we have to calculate the relative atomic mass of rubidium, which is AR. So from the information we obtain from the mass spectrum, we have the ratio of the relative abundance and we have the isotopic mass with AMU. So in order to find the relative atomic mass, so first of all, you need to calculate average mass of rubidium. okay, or average atomic mass of rubidium. And the formula will be the same like we did for AR just now. So summation of QIMI over summations of QI, okay, whereby this QI is the relative abundance. So this MI is in the form of isotopic mass, okay, not relative isotopic mass, tetapi MI ini adalah isotopic mass. So why this is isotopic mass and not relative isotopic mass? Because the mass of a charge in the spectrum here has unit AMU. Okay, so MI cannot be relative isotopic mass. It is isotopic mass. Okay, so by having this informations, now we can insert the values into the average mass formula. So here is the 18, okay, for the abundance, and then 18 is here, and this 85 is the isotopic mass, okay, together with the unit, masukkan sekali dengan dia punya unit, okay, and then plus with the other isotopic abundance, which is 7, with its respective isotopic mass, okay, and over with summations of the ratio, which is 25. So you will get the average mass of rubidium is 85.56 AMU. Okay, so for the average answer, still we can write the AMU. Okay, it still has unit AMU. And then, in order to answer our question that is relative atomic mass, so relative meaning that it has no unit. So, for AR, you must cancel the unit in average. Okay, you must cancel the unit that you have found in the average. So, the way to cancel the unit AMU, so to get the AR equals to the isotopic mass or atomic mass just now with unit, over 1 over 12 times 12 AMU. Okay, so by doing this cancellation, we will get the same figure answer, but without unit. So the answer without unit here is refers to relative atomic mass. Okay, so for this kind of question, if you've been given the mass of a charge with AMU, okay, if you be given this mass of a charge with AMU over here, so what you have to do first adalah you have to calculate the average mass of rubidium. Okay, you have to calculate the average mass of anything. Okay, it can be rubidium, it can be magnesium, and so on. And the second step, later you calculate the value of the AR. Okay, so by having the AMU or by having the unit in the best spectrum for the mass of a charge, you have to use these two steps calculation in order to find the relative atomic mass of rubidium. Let's do this practice together. The neon element has 3 isotopes. They are 90.92% of neon 20, 0.26% of neon 21, and 8.82% of neon 22. Draw and label the mass spectrum of this element, then calculate the relative atomic mass of neon. So, from this information in the question, you can expect in the mass spectrum later on, you will have 3 peaks. The highest one for neon 20, the lowest one for neon 21, and the medium one for neon 22. So let's answer this question A and B. So for question A, you have to draw and label the mass spectrum of this element. So since the relative abundance is given in the form of percentage, you can simply label your y-axis as percentage abundance. And the x-axis will be m over e. Okay, should we put the unit AMU in this x-axis? if you can read the soalan, okay, once again, we didn't see any existence of AMU in the question. So in this case, for this spectrum, on the x-axis, you don't have to label the AMU unit. Okay, so just leave it as M over E or M over Z or M or mass over charge. Okay, all right. And then for the spectrum, we have to label the intensity or the percentage abundance of the peak in this spectrum. Before that, we have to label the M over E. So M over E, we have value of 20, 21, and 22. So these are the isotopic mass. Okay, so these are the relative isotopic mass for neon. So why I say relative isotopic mass for neon? Because M over E has no AMU. Okay, so 20, 21, and 22 are actually the relative isotopic mass of neon. And then you have to label also the percentage of the isotope. So neon 20 has 90.92% and neon 21 has 0.26% and neon 22 has 8.82% of abundance. Okay, so by drawing and labeling this mass spectrum completely, okay, you have done for part A. Okay, and please make sure once again you have to draw your spectrum by just drawing this single line. Okay, you are forbidden to draw like this. Okay, you cannot draw like this. All right, so you just have to draw single lines like this for spectrum. Okay, so that is for question A. All right, now for question B, calculate the relative atomic mass of neon. So as we go back to the question, okay, in the question, it does not mention anything regarding the isotopic mass. Okay, you just have the value of neon 20, neon 21, and neon 22. So these three values should be referred to relative isotopic mass. Okay, so since we already have the relative isotopic mass in the question and in the spectrum, so now you can simply calculate the relative atomic mass of neon, AR, by using this formula, summations of Qi Mi over summations of Qi. Okay, di mana, okay, this Qi refers to percentage abundance. Okay, so this Mi now in this case refers to siapa? It refers to relative isotopic mass. So which one is the relative isotopic mass? Mana satu yang ni? Ini, nilai di bawah ini. Okay, and these values does not has AMU unit. So that's why you can calculate this AR by using a single step. So this is the example of calculation that involving one-step method in order to calculate the relative atomic mass. Okay, so let's move to practice 5. So in this question, the ratio of relative abundance of naturally occurring of chlorine isotopes are as follows. We have chlorine 35 over chlorine 37 with the ratio value 3.1 to 7. Given the atomic mass of 35 chlorine is this value in AMU and chlorine 37 in this value AMU. Calculate the AR of the chlorine. Okay, so now what do we have in this soalan? So in this soalan, you've been given this value okay, of chlorine 35 over chlorine 37 equals to 3.127. Okay, so this value meaning that 3.127 over 1. And also we have the isotopic mass in whole number and also in decimal number. Okay, and also not to forget we have EMU. Okay, we have EMU for the isotopic mass. Okay, so then you have to calculate the value of the AR of the chlorine. Okay, so to answer this question, do we have to use one step or two steps calculation? So what do you think? You can pause for a while and think for the answer. So first step, what you have to do is you have to get the ratio value of the respective isotope. So these are the abundance value for chlorine 35 and chlorine 37. So 3.127 is the relative abundance of chlorine 35 and 1 is the relative abundance for chlorine 37. So in the question, if you still remember, you've been given the value of atomic mass in AMU. So in this case, what you have to do first is you have to calculate the average atomic mass. So this is the answer for the average. So in order to get the relative atomic mass, which is AR, so we can just simply proceed with the cancellation step, di mana you have to divide with 1/12 times 12 AMU. So for this step, you can cancel the unit AMU and also 1/12 and 12. So hence, you will get the answer 35.4528. Okay, the same figure like in average atomic mass, but for AR, it has no unit. So this will be our final answer. So definitely for this question, you have to use two steps method. Okay, the first one, you have to calculate the average atomic mass, and then later you can calculate the relative atomic mass. Naturally occurring iridium is composed of two isotopes, which are iridium-191 and iridium-193 in the ratio of 5:8. Based on carbon-12 scale, the relative atomic mass of iridium-191 and iridium-193 are as given respectively. So for question A, sketch and label the mass spectrum of iridium, and for B, calculate the relative atomic mass of iridium. So what are the important points in the question? We have two isotopes of iridium. They are 191 and 193 iridium, and with their respective relative abundance. And then in the question as well, we also have the relative atomic mass or relative isotopic mass of iridium-191, which is this one, and 193, which is this one, respectively. Okay, so with all these informations given, let's answer the question. So to answer question A, you have to sketch and label the mass spectrum of iridium completely. So what you have to do first is you have to draw the layout of the spectrum. Okay, so please draw neatly, okay, by using ruler, because I don't have one here. So you have to label the y-axis as relative abundance and the x-axis as m over e. Okay, now, and then do we have the unit for isotopic mass in the question? I believe it's not. Okay, so meaning that in the question we have the relative atomic mass. So when we have the relative atomic mass, the value of the m over e has no unit. Okay, so you don't have to put unit for the m over e on the x-axis. Okay, and then from the information given as well, we have two kind of isotope. They are isotope 191 and 193. And their abundance is 5 for 191 and 8 is for 193. So we can say that from these two ratio values, iridium 193 is the most abundant isotope, okay, compared to these two. I label the value of the abundance on top of your peak. So this is the mass spectrum for iridium 191 and iridium 193. Okay, and please bear in mind as well, the value we usually use to label the mass spectrum on the x-axis over here is usually a whole number. Okay, we didn't use any decimal points number to label the x-axis in the mass spectrum. Okay, so we will use we will use whole number. Okay, so this is our complete mass spectrum for iridium. Okay, so let's move on to question B. So in question B, you are required to find relative atomic mass for iridium. Okay, relative atomic mass of iridium. And in the question as well, you've been given the isotopic mass, the relative isotopic mass. So if we already have the relative isotopic mass, so hence now you can calculate the value of AR by using this summation formula directly. Okay, why? Because we already have here the relative isotopic mass. So by having the value of relative isotopic mass, okay, in order to calculate the value of AR, definitely you just have to use one-step method. Okay, so now substitute the value of the QI and MI. So we will have 5 abundance for 191. So for the value of MI, you have to use the one with more decimal points. Okay, so the decimal point, the decimal values should be used in the calculation, and the whole number we will use to label in the mass spectrum. Okay, so since the value here has no unit, okay, since the value here has no unit, so for the final answer, you will get this value, of course, without the unit. Okay, so this answer is actually referring to relative atomic mass. So definitely for this kind of question, you just have to use one-step method in order to find the value of the AR. So hopefully by looking practice 5 and practice 6 solution, you should be able to differentiate which kind of question should be used one-step method calculation and which kind of question that should be used two steps method calculation.
Thank you for watching, everyone. I hope this video could help to enhance your understanding in chemistry. Have fun in your learning, and remember, chemistry is easy and fun.